Today we're going to study triangles. We're going to focus on triangle. So first of all, let's go back to a rectangle and record the formula. Okay. Yeah. So remember, we have a rectangle back definition. It's a right angle here. So this is a rectangle, right? And if this side is A, this side is B, so the area, we know that the area is going to be A times B. So then we also have the definition, the formula for this is definition, okay? And we have a formula for the perimeter, okay? The perimeter is going to be, P is going to be 2A plus 2B because you have a double, right? Identical sides, okay? And also very important thing is how to find the length of diagonal, but I'm not going to talk about it right now, okay? Now, suppose we have a triangle, okay? Suppose we have a triangle. How can I find the area formula so if we don't know the area formula? Okay. How to do that? Just like a puzzle, okay? I want to make it like a rectangle. So what I'm going to do is I duplicate this, okay? Duplicate this, and then so you get a parallelogram, okay? You better carry a parallelogram. Then I cut this part and move it to here, okay? Okay, so let me cut it. This portion, okay, is moved to here. Okay, so now what do you get? You get a rectangle, right? So you know the area is not changing. If this side is a B, if this is a H, so this side is going to be H, right? So the area of the rectangle is going to be B times H. But since you just move this triangle to here, so that is going to be the area of this parallelogram. And the area of parallelogram is double the area of the triangle, okay? That is why the area of the triangle is going to be, the area of the triangle is going to be half of B times H, okay? So next time if I ask, this is a formula, it's not a definition. The area of a rectangle is A times B. So we use that definition to find the area of this rectangle we make, right? Out of the two identical triangles. Okay. All right, so the area is only determined by the height and the base. So let's take a look at the following example. Okay. Yeah, the following example. And let's see. So we have a triangle. Okay, this side is 5. The height is 2. Okay, another triangle. Okay, is going to be, its base is also 5, but it's going to be very, very long. Okay, looks like much larger, right? I did not draw correctly. Let me redraw. Okay, I'm going to put 2 parallel lines. Okay, and another line will be right here. All right, so those 2 lines are parallel, so that means they have the same, let me erase this part. So here, let's draw this triangle. Okay, this is one triangle. Another triangle could be like that. Okay, so if you look at those 2 triangles, these 2 are parallel. Okay, now does those 2 triangles have the same area? The one triangle that's colored in this way. Okay, another triangle we use a yellow color, but there is overlap part, right? Yeah. So those 2 triangles, okay, because the base is 5, the height is 2. So that they have the same area. Which is going to be 1/2 times 2 times 5, okay, which is just equal to 5 square units, right? It doesn't matter how long this triangle, so they have a different size, okay, one-dimensional size. When we talk one dimension, just 1 meter, use a just one, one dimension, just use a strict line to measure it. So the second triangle much longer than the first one, but they have the same height, right? The same base, same height. They look different, and the one looks much larger than the other one, but they have the same area. Okay, this is very important. So you can slide the point P to the left, to the right, but you're not going to change. You're not going to change the area, okay, of the triangle you get. Okay, so it's going to be the same same area, right? Even you make it very long, like 1,000 miles long, then it becomes very slim. Right. So this is a cool, right? And right, so this is very important, right? So now I'm going to talk about. Everybody knows that if you have a given base, given height, you can find the area, no problem. But in basic math class, we are going to study two-step problems, okay? That means you're not given the height and the base directly. We want to find the area, okay? And for example, this is a typical example. If you have a triangle, okay, and I divide this triangle into 2 parts, and this side it's getting 2, other side is a 4, okay? Now, if the area, let's call it A, B, C, and D, okay? So the triangle is denoted by like this, A, B, D, okay? That means the triangle on the left, okay? The triangle on the left, okay, we assume that it has area, okay, if the area of the triangle, let's just say if this triangle has an area of like the area of 3 square units, okay? My question is, what is the area of the triangle on the right-hand side? Of the triangle ADC, okay? Now, how do you solve this problem? You look at the triangle on the right-hand side. You are given the base, right? You are given the base, no problem. The only problem is here is what is the height, okay? So these 2 triangles have the same height because they have the same context, vertex, right? So these two triangles have the same height, as you see that. The question is, what is the height? If you figure out the height, you can get the area, right? Okay. So what is the height? You have to use the information for the area of the triangle on the left-hand side. Okay, have the same height h. So let's find out h. What is h, right? So the area of the triangle ABD, right, is going to be the base, half of the base times height, and which is already known as 3. So what do you get? Get h is going to be 3, right? So that is the height. So once you get height, then you will get the area of the right triangle on the right-hand side. So the triangle ADC is going to be, the base is going to be 4, and then height is going to be 3. So that's why if you multiply them half, that's going to be 6, and the square units. Okay, so this is a very interesting problem. Now you have to use a, yeah. So you have to figure out the height. Okay. 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 So our next problem is, let's take a look at this. Is a right triangle, right? If you're given a right triangle, here's 2 and 3, right? This is a right triangle. Then we know how to find the area, right? So area, this is, right? So the area is going to be, right, is going to be half of the base times height, which is 3. Okay, no problem. Okay. Now, if I ask you to, I change the problem a little bit. If here's 2, this is a 3, and here's, this is 3, this is a 4. Okay. Now, what is the area of this A, B, C, and D? So what is the area of this triangle? Okay. Yeah, what is the area of this triangle? What is the area of this triangle? Because you already know the height. 2 is the height. So you just say half of, okay, the base is 4, and the height is 2. So which is going to be 4. Okay, no problem. Okay, now sometimes you have to figure out whether this triangle is a right triangle. If you know it's a right triangle, you just use the area formula, right? Now, how to check whether the triangle is a right triangle? So if you, it looks like a right triangle, but it's not necessary, okay? Now, this is a A, okay? This is a B, and that's a C. So it is the Pythagorean theory says that it is a right triangle if and only if a squared plus b squared equals c squared. That means as long as the 3 sides satisfy this equality, then this is the right triangle. And the angle between A and the B is the right angle. Okay. So then in this case, if it's the right triangle, then the area is going to be A times B divided by 2. So in this case, okay, in the case of its right triangle, the area is just equal to A times B. You don't need to worry about C, okay? And so given a triangle like that, okay? So 3 and 4 and 5. Now this is a very interesting triangle. It was actually observed by a Chinese, we find out in the literature thousands of years ago, okay? And they find out if it's a right triangle, then if you go north 3 steps, go east, right, 4 steps, then along the diagonal it's 5 steps, so it's recorded. But the Chinese never got this general formula. They only find out if it's a right triangle. So conversely, if you can see this equality holds, okay, then this implies it is a right triangle. Now you are not told it's a right triangle, but I told you the Pythagorean theorem says that if you have this relationship, then it's a right triangle. So the angle between 3 and 4 is 90 degrees. Okay, so then the area is going to be just needed. You just needed to do this multiplication. It's going to be 6. Okay. Uh, yeah. All right, given another triangle, maybe I write it in this form. Okay, it is going to be 12, 5, and 13. Okay, what is the area? Okay, the only formula we can use right now, right, is going to be the height, right? But I cannot find the height. It's so complicated. We can find the height later, okay, in the advanced math class. But okay, but this one looks like a right triangle, so we have to check. Okay, let's check. So 5 squared plus 12 squared is 25 plus 144. It's going to be 169, which is a 13 squared. Aha. So this relationship holds means it is right triangle. Okay. If it's the right triangle, the angle between then you can put it in this form. Here's a 5, here's 12, here's 13. So this is the right angle. So therefore, the area is going to be 5 times 12 divided by 2, which is 30, not 60. Right, divided by 2. Okay, so you have, this is a special triangle. We know it's a right triangle. All right. Now, once you know the area, can we find the height h? My question is, what is the value of h? Is anybody can figure it out? Based on the information you already got and they give it. I'll give you a half minute to think about. All right, so some of you give me an answer. Okay, it's Nina. Yeah, almost there. Just be careful when you do the computation. All right, so you already know the area. Area is 30, right? So the area is 30. But you can calculate the area in a different way, right? The base is 13 times the height divided by 2. So now, as long as you can write down this, you know how to find the height. This is pretty tricky, right? So that's going to be you multiply by both sides by 2, so you get 60, then divide by 13. So this is the height. Okay, just one step. Okay, so we cannot find the height directly, but we verify this is the right triangle, so we can go around and then find the height. Okay, yeah, using the area to find the height. Of course, you can use the height to find the area, but if you know the height, okay. All right, so now we'll continue to use Anyway, if we know it's a right triangle, it's easy to find the area. Okay. So now let's take a look at the rectangle. Okay, this is a rectangle. By definition, rectangle, all the angles are 90 degrees. And I'm going to draw, pick up a point here. And this is there. And they're going to be like that. Okay, oh, sorry. Right. So this side is 3. This side is, let's call it the middle point, 3. And here's 2, here's 1. Okay. So my question is, what is the area of this shared region? This triangle. Okay. If I use a point M, N, M and let's say O. So what is the area of the triangle M and O? Right? All right, so now how do you find the area of the triangle? Base times the height. Can we find the base? It's almost impossible. Let's call it, A and B and C. Okay. And I don't think it's the right triangle. The chance is very low. Okay. But I don't know what is C. I don't know what is A. I don't know even the height. Right? Yeah. So Nina got the right idea. Use a subtraction. So when you're trying to solve a math problem, okay, like geometry, don't just focus on this triangle. You step back to look at this triangle where it is. It is inside a rectangle. It's surrounded by 3 right triangles. It's great. You know how to find the area of the rectangle. You know how to find the area of the right triangle, right? So use a subtraction. Okay, then you can get the area of the triangle, yellow triangle. Okay. Okay. So so the area of this triangle is going to be the area of the rectangle, which is 3 times, I think 3 times 6. Okay, not 3 times 3. Okay, 3 times 6 because the length is 6, the width is 3. Then you minus the area of the triangle on the left up corner, half of 2 times 3. Then this side is 3, right? So then you look at the area of the triangle at upper right corner. Then you look at the area at the bottom. The area at the bottom, the base is going to be 6. The height is 1. So you simplify this, you solve the problem. Okay, right? So just subtract the area of the right triangles from the area of the rectangle. Then you solve the problem. Okay, so it's going to be 18 minus 3 minus 9 over 2 minus 3. Okay, let's continue. So 18 minus 6 is 12. And 24 minus 9, 15 over 2. Okay, so 15 over 2 is the right answer. Okay, be careful, when you do the computation. Now, are you able to determine the length? Are you able to determine the length of each side of the triangle? Yes, but you have to use a Pythagorean theory to do that, okay? So a squared, let's apply the Pythagorean theory, okay? For practice. They're very strange side. So for example, a squared is going to be 2 squared plus 3 squared, right? Just apply the Pythagorean theory. And it's going to be 4 plus 9, it's going to be 13. So what is A? A is going to be the square root of 13, very strange number. right? And the same b is going to be, b squared is going to be 3 squared plus 3 squared. It's going to be 2 times 3 squared. So b is going to be 3 squared root 2, right? It's also a straight number. And the c squared is going to be, what is the other side? It's a 6, right? 6 squared plus 1 squared. 36 plus 1 is going to be 37, and even worse. So you see that those are very strange 3 sides, okay? And, you know, if you really want to compute it. But let's go back to this problem again. We use a subtraction method to solve the problem, okay? So the yellow triangle surrounded by 3 right triangles, okay? So you just needed to subtract the area of the 3 triangles from the area of the rectangle. So what is the area of rectangles? The rectangle, the length is 6, the width is 3. So 3 times 6. Then you calculate the area of each right triangle. That's it. Right? You calculate the area of the right triangle. Then you subtract it from the area of the rectangle. Okay? Okay. So that's it's not 3 times 3, okay? 3 times 6. Yeah, do you get? Okay, great. Okay, the idea is just use subtraction method. Okay. So I'm going to ask you to do one more problem like that. I hope you understand. Okay. So here is going to be the triangle. This is a rectangle. Okay. So I'm going to put, yeah. So it sounds like that. Okay. This is connected. Okay. Now, okay. Now this is side different, right? So this side is going to be, yeah, this side is going to be 4. Here's 2. Here's 3. Here's 1. And this is going to be 6. It's 1 and the 3. Okay. So what is the area of this triangle? Okay. What is the area of the triangle? Can you do that? Well, this triangle is a little bit special. Okay. Why? Because you don't need to use a subtraction here. Right? You don't need to use a subtraction here. The reason is the base parallel to the edge of the rectangle. So the height of this triangle h is just equal to 3. Okay, so that's why the area is going to be half of the base times 3. So that is going to be 9. Okay. All right, so now I'm going to give you another one. This is a fixed point, and here's a 1, that's 2, that's 1. And I have another point P here. So this, how does it look like that? This is a, okay. This is a rectangle, and here's a 3, okay? This is a rectangle. Now, question is, when I change the point P, this is a research project, okay? Does the area of the shaded region depend on P, the location of P? That's a question. I'm not asking you to find the area. Does the area, the total area of the shaded region, depend on the location of P. All right? And if not, what is the area? Can you find the area? Okay. The area of the shared region consists of two triangles. So the shared region consists of two triangles. Kenny's got the answer? And Crystal says, think so. Okay. Now you cannot say think so, you have to prove it. Okay. You have to prove it. All right. So how do we solve the problem? I don't know the area of each triangle, but the sum maybe is constant, is fixed. Okay. Let's call this one A, that is B. Okay. So the area of the triangle on the left, okay, is going to be half the base times the height, right? So this is A1, that's A2. So A2 is half of the base times height. Okay, we still don't know A and B. But let's add them together. I get half, 3 halves A plus 3 half B, right? Then I have a common factor. So I take 3 over 2 out to get A plus B. Now what is A plus B? A plus B is the length of this rectangle. I don't know the exact value of A and B, but I know the sum, which is going to be 4. So that is going to be 1 plus 2 plus 1, which is 4. So that's why 4, and then it's a 6. And multiply them. All right, A plus B is the length of the rectangle. So this is a pretty tricky problem. Right? Let's try again. I'm going to look at this. This is a square. Okay, it's a 4 by 4 square. So what I'm going to do is I pick up a point, 1, 1. I connected it. Okay, what is the area of this? This is an isosceles triangle, right? What is the area of this isosceles triangle? Yeah, please find out. And this is a 4 by 4 square. I'm talking about the triangle ABC, okay? Sorry, not the little one. The triangle ABC, the larger one. Anyone get answers? Kenny's? I have to call your name. Casey, do you have answer? Charles? Oh, Charles have answer. Great. Edward? Jessica, how are you? Do you feel more difficult right now, this courses? Yeah, use a subtraction. You know the formula for the area of a triangle, right? Just one single formula, practice. Okay, so we use the same idea. First of all, the area of the square is 4 times 4. Then we subtract the area of each right triangle surrounding it. Okay. So the little one is 1 times 1, right? Then the one on the left, on the right side, it's going to be 3 times 4. Then the other one should be the same, 3 times 4 divided by 2. All right? So it's 16 minus 1/2, and 3 times 4 is 12. Okay? So that is going to be 4 minus 1/2, and, and the 7 over 2. Yeah, we prefer use fractions, okay, not decimal form. Okay. Right, got it? Yeah, if it's not easy to find the area of the isosceles triangle, but like something like this, let's look at the isosceles triangle, okay? And that is going to be 5, 5, 6, okay? What is the area of this triangle? This is an isosceles triangle. Okay, you're not given the height. Okay, so you're not given the height, but if you want to apply the formula, you have to draw the line. This is a height. Then because this is an isosceles triangle, so it divides, this line divides the isosceles triangle into 2 identical right triangle, right? And once you divide a right triangle, you can see that this is going to be 3. So the height by the Pythagorean theory, right? H squared plus 3 squared equals 5 squared. Then H must be equal to 4, right? So once you figure out 4, then the area is going to be half of 6 times height, which is going to be 12. Okay, the height is 4. Got it? Okay, Calvin. Okay, so that is now if you use this idea, you can find the area of more generalized isosceles triangle. Just the height might not be a rational number. Okay. All right. So now question is, what is the definition of trapezoid? A trapezoid is a triangle cut off another triangle. So this trapezoid is just like that, okay? So those 2 lines are parallel by definition, okay? So how do I find the area of trapezoid? Okay, how to find the area of trapezoid? What is the information I need? Okay, I can tell you this is a height, this is A, that's a B. So let's figure out the formula. Okay, let's figure out the formula. So please turn off your video. Kelvin, yeah. Right. Now, of course, you already learned the formula somewhere, and then you can give me the answer, right? But we can derive the formula. Okay, how do you do that? Well, you duplicate the trapezoid and then put it together like that. Okay, so you get the parallelogram, and the length of the parallelogram is going to be B plus A, right? And the height is H. So the area of the parallelogram is H times B plus A, and you divide by 2. So it's going to be B plus A times H, okay? So that is the area from it. Okay, but the most important thing is that the trapezoid has the 2 lines of parallel, okay? So let's take a look at the following problem, okay? So you have the trapezoid, okay? And what do I know? Okay, I know, so this is a 3, that's a 5, okay? I know the height is 2, okay? So the area of this trapezoid is half of 3 plus 5 times 2. So this is going to be 8, no problem, okay? Now, if I give you another trapezoid, okay, this is a 5, this is 3. I'm not given the height, but I already know the area of this triangle. So if the area of the triangle ABC is going to be 4 square units. So question is, what is the area of the trapezoid? So you cut off you divide this trapezoid into 2 triangles, right? And if you know the area of the one triangle, one of the triangles, can you figure out the area as a whole trapezoid? Okay, how do you solve this problem? Record the formula for area trapezoid. You just need to know is going to be A plus 3 plus 5. What is missing is the height. Okay, that's just step by step. There's no trick here, right? So after simplifying, it's a 4 times H. All you have to do is to find the height. Find the height. Can you find the height? Can you find the height? Well, you haven't used the condition. Area of the triangle ABC equals 4. So using that, let's write the area of the triangle ABC, right? Which is going to be 4. But you can calculate the area using this formula, the base times height. The base is 3, the height is H. Okay, so now you end up with H equals 8 over 3. Okay, so that is 8 over 3. Therefore, the area of the trapezoid, let's call it ABCD, is going to be 4 times H, 32 over 3. 32 over 3, Charles. It's not 8 over 3. Yeah, 8 of 3 is just the height, yes. Okay. Good. So I'm going to ask you to do the following problem. This is a trapezoid. Okay, is this 3 and that's a 5. Okay, again. And this A and B and C and the D. All right. So what I'm going to do is I draw the line parallel to this A, B, C, D, E. Okay. So A, B, and C. Well, we assume they're parallel. So this side is 2. This side is 3. Okay, we got such information. What I'm given is the area of the triangle. If the area of the triangle ACE, which is going to be 4. So what is the area of the trapezoid? Yeah, no, actually, what is the area of A, B, D, E? Okay, this one. Okay, let's figure it out. Come on, Kevin, always turn on the video. Don't do that, okay? Right, have you any answers? Whoa, there's so many different answers here. 16, 12, 12, 12, 12. Crystal says 12. Zachary says 12. Okay. Now we're not going to prove this way is a parallelogram. Okay. It might be, it might be not. It's not easy to prove directly. Okay. We just want to find the areas in shared region. Okay. How to do that? Use subtraction. If you're able to find the area of the trapezoid and then subtract the area of the triangle, and you get the areas, right? Area of the shared region. So how do you do that? Well, just need to find the height. What is the height? Okay, what is the height? Right, the height is the area. Okay, so the height is the area of 3. Here's 2 times the height is going to be the area. So height is going to be 4. Okay, so once you get height, then you can get the area of the trapezoid, A, B, C, D. Okay, so it's going to be 3 plus 5 and times 4. Okay, 3 plus 5 times 4. So it's going to be 16. Okay. So that is the area of the trapezoid. The area of the shared region, you have to do subtraction. Okay. Area of the shared region, A, B, D, E, is going to be 16 minus 4. That is 12. Okay, don't forget. Okay. Okay, given a triangle with 3 sides. Okay, so it's going to be 8, 6, 3, 65. What is the area? Okay. Well, at this moment, okay, we don't have a general formula for the area of the triangle once they give us 3 sides. But we can, when you see 3 numbers, the first thing that comes to mind is it the right triangle or not? If it is, let's check it. Okay. So you get 8 square plus 63 square. Okay. Okay. Then you find out it is given 64 plus 390. Add them together, 3,969. Add them together is going to be 3 here. I think it's 4,033. Right? No. 4,000. Yeah, 4,033. Okay. So this is not going to be a square, perfect square. It's not going to be 65 square. It's not going to be 65 square. So it's not a right triangle. Then you say, I'm stuck here. So we don't know how to find the area, right? If I change 8 to another number, maybe. Let's take a look at, right? 65 square minus 63 square. Right. So if I double it, right, if I give you another 63, 65, let's try 16. Okay. If you try 16, yeah, it ought to be 16, right? Then you will see that 16 square plus 63 square equals 65 square. That's great. Okay. Now in that case, yes, it is easy to find the area. Okay, let's double check. Okay, 16 square. Okay. Yeah, it is true. Okay, so then it is right triangle. In this case, the area A is going to be half of 16 times 63. Okay, and you multiply this out, you will get you will get 63 times 8, 504. Now, we still have a question, how to find the area of the first one. Okay, how to find the area of the first one if it's not a right triangle. Okay, so there's a guy in the history called Heron. Okay, he find out once he given 3 sides, A and B and C. Okay, and I can calculate the area using those 3 numbers. And this is going to be like that. And where S is half of the parameter. That's interesting. So we're now going to see how, he's so smart and discover this. But this is a good formula. Okay. And then doesn't matter which side, what kind, it can give any numbers. As long as they form a triangle, then you have this formula. Okay? Then you have this formula. So this is a very useful formula. For example, I randomly write down a number, it's a 3, but this time I'm going to use a 5. 3 times 5, and I put, how about 7? No, I'm going to use, I'm going to change 3, 6, and 7. Okay, so this is a, okay, so 6 plus 7 greater than 3, 3 plus 7 greater than 6, 6 plus 7 greater than 3. Okay, so you can find the area, but this does not satisfy Pythagorean theory. Okay, it does not satisfy Pythagorean theory. Okay, okay. So S is just, this S just represent the half of the parameter. Okay, so I just say where S is given by this formula. Okay, okay. So first of all, you calculate the parameter for this problem. 3 plus 7 plus 6, so 16. So it's gonna be 8. Okay, then according by the Heron's formula, it's gonna be 8 minus 3, 8 minus 6, 8 minus 7. This is a very useful formula, I tell you, right? And you multiply this out, it's 8 times 5 times 2 times 1. I think we are able to take 16 out. 8 times 2 is 16, so it's 4 square 5. See, this is the area. 4 square 5, perfect. Get a radical number, right? If the 3 sides are integer, then the area of this triangle is going to be rational number. Okay, yeah. So this is a very useful formula, I just tell you. Okay, so let's go back to the formula here. Now, if you know it's a 3 and the 4 and the 5, and you can also apply this formula to check whether this formula is correct, right? So S is half of 3 plus 5 plus 4, which is going to be 6, right? So the area is going to be 6, 6 minus 3, 6 minus 4, 6 minus 5. And I get 6 times 3 times 2 times 1. So I get 6 squared, then I get 6. Okay, this is, you can compute it directly. Yeah. Yeah. Oh, the time is up. So I stop here, okay? And yeah, we are going to get homework after, no,